Testing. 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 It's testing, not testing. Does this work? Alright, I think it works. Audio working? Alright. Go ahead and do this. Welcome to another stream. No paper today. We're going to be doing just some hanging out and coding. I got a couple different things on the agenda. So, the code interpreter. People have been kind of talking about that coming out, so I definitely wanted to check that out. Code interpreter is kind of like this Jupyter notebooky kind of thing that OpenAI released, where basically you can kind of like code and it kind of like runs Python code for you. But people have been talking about it, so I wanted to check it out. Another thing I wanted to look at today is Keras Core. So Keras is an older framework. It's actually one of the first frameworks that most people learn. And it's also the product of this guy called Francois Chalet, who's a very famous ML researcher. He had a book that he wrote a long time ago that I actually read back in my journey into machine learning. But apparently they just released a new version of it that allows you to switch between TensorFlow and PyTorch. So kind of curious to see what that looks like. Yeah, Keras Core. That's what they're calling it now. Full rewrite of the Keras codebase that rebases it on top of a modular backend architecture. Makes it possible to run Keras workflow on top of arbitrary frameworks starting with TensorFlow, JAX, and PyTorch. So PyTorch is by far the most popular one at this point. Pretty much everybody uses it, and it's the best, you know? TensorFlow used to be good because it was kind of the only one, but it's really fallen out of favor. It's unnecessarily complicated, and it has too many pieces, too many things that kind of do the same thing. There's like 10 different data pipelines, you know, like 10 different ways of loading models and saving models, and it was just confusing and unnecessary, and I feel like over time PyTorch won out. And then there was a faction within Google that created this other one called JAX, which is pretty good. It has its own advantages. It's really cool in the ability that it lets you use multiple hardware devices in a kind of like interesting way. But Keras is also more so associated with Google. And if JAX is about kind of vectorization and speed and being able to parallelize things across a bunch of hardware, I would say Keras is more about simplicity and readability. To me, it's like Keras is designed for kind of like people who might not know much about machine learning and they want to write like a training script or, you know, something simple. They want to write their own model. So if you're doing things from scratch like that, then Keras is great because it's very readable, it's very easy to learn, and it kind of teaches you the basic concepts of deep learning. But that's what Keras used to be. I don't know if that's what they want out of Keras right now. You know, maybe they're trying to make Keras a little bit more performant, make it more of a PyTorch competitor. But let's see. Drop in replacement near full backwards compatibility. That's a little bit sketch, you know. Backwards compatibility is great, but if it's near backwards compatibility, that's almost worse, you know, because at that point you're going to try to do something that's not going to work. Did you ever do any coding along with Dino V2? You mentioned doing some simple feature extraction. I'm interested in using it for unsupervised image clustering. I don't recall anymore. You can, so I do have, like, this is a project that I was going to work on today. If we run out of things to do, but this one does kind of what you're saying. So in this project, I'm using the segment anything model, and I'm using specifically the, or maybe not. Here, this is what I meant. Okay, never mind. So the XL version of Stable Diffusion, which is the most recent one, you can get the VAE, right? The Variational Autoencoder, which is basically how you encode the images for use with the diffusion model. And this Variational Autoencoder here, this is how you basically use it. You just load it. You need the YAML file, the save tensors file, and then you can encode your images like this. So, to answer your question, Asa, depending on what you want to do, there's probably a different image encoder that you could use. I think the Dino V2 one is probably one of the more generic ones, so it depends on what kind of image clustering you want, but look at the segment anything model for a cool kind of image encoder. But if you really want to use the Dino V2 one, let's see. PyTorch code models V2. Yeah, I mean, here you go. So it's this easy. Import torch. You load the model here. They have a couple different sizes, different vision transformer sizes, and then you probably just have to take this and give it an image. Yeah, I would just follow the instructions on this GitHub. Okay, let's go back to Keras core here. Big return to our multi-backend roots. Theano. It's a very old. I think Theano actually led to PyTorch. Is that correct? No, it's different. Yeah, I mean, these are ancient deep learning architectures. And also the deep learning architecture just matters less and less, I feel, because the model architecture matters less. I feel like in the 2010s, there was a lot of work on kind of iterating and creating new model architectures and adapting them and so on, and training things from scratch. But I feel like those type of things are less and less important, so that means the framework is less and less important too. The 2022 Kaggle Machine Learning and Data Science Survey. What is this? Executive summary? Is this going to tell us how many people use Keras? An increasing number of data scientists are living and working in Japan. Huh. Python and SQL. Dude, SQL is the language you use for databases. R is basically like a shitty version of Python. It's kind of more like MATLAB too. It's a statistical kind of scripting type language, but I think it's quite old at this point. Python is kind of dancing on the grave of all of those. But yeah, SQL and Python is a powerful combo. What do we got here? Visual Studio, Jupyter Notebooks. Jupyter Notebooks count as an IDE? I don't know about that. MATLAB counts as an IDE? And then, of course, Jupyter Notebooks, there's different flavors of them. Jupyter Notebooks is, I think, the original kind of brand, but obviously Colab, which is Google's version of that, is effectively a Jupyter Notebook, and then Kaggle has their own kind of Jupyter Notebook clone as well, or fork or branch. I don't believe this. This is saying that there's more people using TensorFlow than PyTorch and more people using scikit-learn than PyTorch? That doesn't make any fucking sense. This conflicts with what I see here. Yeah, I mean, look at this trend here, right? Look at TensorFlow here. In 2019 was 27% of repos, but now you come over here, TensorFlow is 3% of repos. So I think this might be, I don't know, which one do we trust more? Do we trust the Kaggle Data Science Survey, or do we trust the Papers with Code kind of scrape? I think this is scraping a bunch of repos, a bunch of GitHub repos. I would say I feel like this is more true. Like I would say, I kind of agree more with this, where I feel like everything is PyTorch and then TensorFlow is tiny. In fact, JAX is pretty much probably bigger than TensorFlow at this point. But this makes it seem like there's still a bunch of people writing TensorFlow code. And scikit-learn is like, yes, it's popular, but it's like nobody actually uses it for like actual real things, you know. It's more just for like a baseline or like a toy problem. Transformers, cloud computing, AWS. Yeah, that would make sense. AWS is definitely more popular. Frequency of TPU. I think this depends on whether or not you're a Google employee or whether or not you use Colab a lot. Okay, all right, that was kind of pointless. While PyTorch has been between 40 and 45% market share and is the top choice for ML research, I agree with that. TensorFlow has between 55 and 60 and is the top choice for production ML. I disagree with that. I think Google's holding ahead to Francois Chalet's head and forcing him to write this. Well, having a much smaller market share, blah, blah, blah. Always get the best performance. Maximize available ecosystem surface. What? Okay, so here's kind of the main thing here is that your Keras core model object, you can instantiate as a PyTorch module, which is kind of the model object equivalent, a TensorFlow saved model, or a JAX function. Write one model.py and get access to everything the ML world has to offer. But I feel like the hidden assumption here when they say that is that you're still writing model.pys, and I think that's the mistake there, is that nobody's really writing model.pys anymore, right? Nobody's writing a model from scratch. You're fine-tuning a model that somebody else has trained. So Keras was more of a thing when people many times with this TensorFlow data pipelines. You can train a Keras TensorFlow model on a PyTorch or train a Keras core PyTorch on a dataset. That's kind of cool, but like, what is the kind of purpose of that? You know, does that actually serve a function? Is there someone who wanted to do that, or is that more just like a weird trick? Near full implementation of the NumPy set of network-specific functions. Is Keras core? Can we pip install this? Progressive disclosure of complexity. Keras doesn't force you to follow a single true way of training models. Instead, it enables a wide range of different workflows. This is part of the problem, though, is that this isn't a feature. This is oftentimes a negative, because the more ways there are to do the same thing, the more confusing it is to do that thing, right? If there's just one way to do it, then every single Stack Overflow thread or every single time you ask one of these LLMs to help you with the code, there's only one way of doing it, so it's very clear how to do it, and all the examples point you in the same direction. But whenever you have lots of different ways of doing things, it becomes more confusing because different sources will tell you to do slightly different things, and then you're not exactly sure which one you're even doing, and you end up kind of combining them in a way that doesn't work, and it's much more difficult to debug and understand. Here's Francois Chalet's email if you want to DDoS him right there. Holy shit. Import order. Weird bugs with pooling. It will be released. So it's not even fucking released yet. Fall 2023. Dude, why? Why spend all this time publishing this if it's not even ready yet? All right, well, that's a nothing burger. All right. Let's look at the code interpreter. Can I add something? Upload a file? Can I upload? Let's upload a picture. This webcam.png that I took. I have a camera on my ceiling that's pointed at this green screen area over here. So let's see if I can upload a picture. Home. Dev. Simcam. Data. Webcam. Here is a PNG of my camera, of my tracking setup. Can you tell me some information about this image? Let's see if it can like analyze an image. Working. What happens when we hit this show work? So it's using the Python image library. It's opening the image. You see this dash mount here? So dash mount means it's a mounted drive, which means that, to me, this means that there's a Docker container, is where this is running inside a Docker container, and it has a mounted drive, which has all the files that you upload. Image info, image mode, size, width, height, format, PNG, RGB, 320 by 240, 320 by 240. Is that actually 320 by 240? Properties. Image. Yeah, it is 320 by 240. Okay. Can create a plot for me. A histogram plot for the pixel values. Does the show work? Okay, so it's using matplotlib. It's pretty generic plotting. Package, NumPy, of course, everybody's favorite Python package. Converts the image into an array. Flattens the array into red, green, and blue channels. You see how it's selecting the correct channel there. Whoa. Then it makes a figure, histogram, legend, X label, Y label, grid, PLT show. Why can't I see it? Can you show me the histogram? I can't see it. All right, so I mean, it saved it to the same folder, this dash mount data. And here you go. Here's a pixel histogram. That's pretty useful. You know, you look at that, you see there's definitely kind of a little bit of some kind of pattern here, which makes sense, right? The image that we gave it is actually mostly this green screen. Right? Let's see if we can get it to flip the image. Can you flip the image for me? Flip the image vertically. See, it keeps like just dumping everything into this data folder here. It's using the PIL image library to do the flipping. You can view or download it by clicking here. What is this link? Inspect. Cursor pointer, click here. I don't even know where that link is leading me to, but okay, there we go. We have the flipped image. That looks correct. What else can we do here? How else can we try to mess with code interpreter? So I know one thing that we can do is I feel like from one of our previous projects we made a bunch of CSV files, so I feel Paperbot, right? Let's go into Paperbot. Here we go. We have Paperbot databases here. Let's copy this one. And the tricky thing about that actually is that it doesn't have code interpreter, and let's add the Paperbot database, but the Paperbot database isn't called .csv, it's called .emoji. We gave it a weird file name, so I'd be curious to see if it can figure out that it's a CSV file. Let's do that. So let's go into Paperbot, into data here. Oh, nope, not license. Into... This is probably very tiny, so you guys can't actually even see what I'm looking at here, but I'm just giving it the Paperbot CSV file that we were using as our kind of mini database. Yeah, this one right here. Failed to get upload status. What does that mean? It's dying? Can you interpret this file for me? Let me also do this as well, just so. This is my GPU. Show work. Okay, so this is the file, and as I said, the extension for this file is an emoji, but it is a CSV file. So it just assumed it was a CSV file, and it was able to get it. All right, so that's interesting. File appears to contain data related to research papers. It seems that each row represents a paper, but the data is not correctly formatted into distinct columns. The first row appears to be ID, title, URL, authors published. Those are the correct ones. But this time treating the first row as the header and each subsequent row as a separate data entry. Okay, that's impressive. So it was able to figure out that this is a CSV file, and then figure out that, okay, because this is a CSV file, I need to make the first row should be the headers, right? The headers are basically like the names of the columns. And that's what it did here. right? Header equals 0 as in the 0th row. And it used the correct separator here. You see the separator here is a tab, and here the separator is a comma. And CSV means comma separated. Here are all the columns. Look at this. These seem to be numerical features, possibly some kind of embedding or feature vectors associated with the papers. Embeddings are often used in machine learning to represent complex models like text in numerical format that a model can understand. This is correct. Those are the embeddings. I think they're actually the embeddings of... we used OpenAI's embedding API to give embeddings for the abstracts. Only one entry. Let's upload more documents. Let's upload the other ones here. This is also, here is another CSV in the same format. Can you join them together? I mean, so far so good with Code Interpreter, you know? It's actually quite powerful here. It's figuring out, it's able to interpret images, it's able to interpret CSV files that are obscure. Finished working. What did it do? Okay, so it's still doing the same thing where it's basically putting everything in this data folder, which is, and it's opening it with the comma separator again, assuming that the first row is header. Here it's using pandas. You see this pd dot concat here. It's just concatenating the original data frame from above and then the data underscore 2. And this to me tells me that it has some kind of Jupyter notebooky kind of abstraction in the background, right? So it already created this data variable, and then you see when we gave it a new one, it created a data underscore 2 variable. So if every single one of these things was from scratch, it would have basically loaded both of the files here. But the fact that it used a different variable like that tells me that it's all just one script, and it just keeps adding to the same script. Dataset now contains 4 entries. Okay, pretty cool. Here, let's do something tricky. So the name of the archive, right, this archive URL, this is the date here. So, or user submitted date. I'm saying, can we ask it to rank it based on something tricky? Or how about this? The authors is a comma separated list. Let's ask it how many authors are in each. How many authors are in each row? Can you add a column for the number of authors? Let's see. Combined data, num authors. So the combined data frame is the one that it created above by combining data and data underscore 2. It's using this dot apply pattern. So this is a pandas pattern where you can take one column and then dot apply a function to it, right? Map a specific function to it. And here the function is just a lambda function, which is syntactic sugar in Python for writing functions in a single line. So this function here will just take x as input and then return x.count comma. So it's actually counting the number of commas and then adding 1. This is kind of clever. This is a clever way of counting the names when you have a string of just comma separated names. You just count the number of commas and then add 1. That's a little clever. All right, and then it just displays title and then num authors. Look at that. It's pretty good. Oh, look at that. It even has a little data formatted like data table kind of appearance. Huh. Pretty cool. Let me know if you need further help with this data. All right. I'm impressed. It even has a table layout, yeah. I mean, they have to have good front-end people at this point, right? It's like, I feel like months ago, OpenAI, before they got all that Microsoft money and before they got famous, right, there probably wasn't any front-end people there, you know? But I bet you that they've hired some pretty strong front-end people, and that's why you're starting to see, like, just everything is cleaner, too. If you notice in the UI now, you can, like, go like this. You see how, like, whenever I click it, like, the top drops. The transitions are cleaner. The buttons are smoother. They're, like, more round. You have tables here, so they definitely have some powerful kind of front-end people working there now. Cool. Why don't we try to do something that for sure it's not going to know how to do? So I have a Docker file here for this SAM, segment anything. So I have a segment anything kind of service that runs inside a Docker container. So let me see if I upload a Docker file, whether it knows what to do with that. So let's do a new GPT-4 code interpreter beta. Let's upload a Docker file and then see what it does with it. I really need a better way to get to the folder that I want here. Tell me more about this file. Let's see if it knows what a Docker file is. There we go. Docker file is a text document that contains all the commands the user can call on the command line to assemble an image. Supports a set of commands that you can use to assemble an image. You can also add comments by starting with a hashtag. It's still using this same folder here. So here it actually read the Docker file, but it read it into one line. Docker file creates a Docker image, PyTorch version 2, CUDA 11.7, upgrades pip, clones the mobile SAM repo, here's the tricky question. Can you write a terminal command to build and then write the terminal commands to build and then run this Docker container? Let's see if it gets that right. You can use the Docker build. Okay, that's correct. That's also correct. And this is also correct. In fact, I like this --rm. I don't actually do that, so I'm going to add that to my thing here. So I kind of do this the more manual and tedious way. So every time I build this Docker container and I run it, I don't have this --rm flag here, right? But the problem with that is that because I don't have this --rm flag, I accumulate Docker containers, right? So then I'll go and I'll get rid of my Docker containers manually with these commands, but it's actually cleaner if I just do this --rm flag. So there you go. Code interpreter helping me out. All right, let's do another tricky thing here. What else can we do? you guys want to give it this .pt, so this .pt, this is a PyTorch checkpoint. It's a PyTorch model, basically. This is for the mobile SAM, so this is a small version of the segment anything model that I use here locally to do segmentation. But let's see if it can actually read and interpret a PyTorch file, or PyTorch model. Documents. No, I want dev semicam checkpoint mobile sam.pt select. Explain this file to me. Appears to be a PyTorch file indicated by the .pt. That's correct. Popular open source framework, blah, blah, blah. Typically PyTorch serialized, which can contain model tensors, blah, blah, blah. Okay. Commonly used to save and load trained models. That's correct. It's hard to determine the exact contents. Yes. Please try to load it. Tell me what's in it. Import torch. Torch.load. Okay, and it ran into an error. So the error here is TQDM. It doesn't have this dependency. Yes. I like how it's suggesting things, right? It's not like a ChatGPT that'll just sit there and wait for you to tell it everything to do. The code interpreter has a little bit more agency. It like wants to do things. So it's like, hey, would you want to open this? Like, do you want me to print out all the keys for this? Hey, here, do you want this? So here you go. It's looking at the ordered dict. It's looking, right, this is a segment anything model, so there's a couple of different pieces to it. There's the image encoder, the prompt encoder, and the mask decoder. Those are correct. Likely responsible for transforming the input image into a format or representation that the model can understand and process. The prompt encoder responsible for processing some sort of auxiliary input. Okay, so it kind of correctly inferred that. Mask decoder. Image and non-image inputs such as image captioning, object detection, or image segmentation. Does Code Interpreter use a different model from GPT-4? It seems like it does. Kind of, and I think that it might even be GPT 3.5 or like a version of GPT 3.5 that's been additionally fine-tuned on code, because I think GPT-4 is good, but it's just very expensive, so like they don't want to have to use it all the time. So I think for things like I don't know, it's not entirely clear, right? Because it's like they don't tell you. So like even though you're going here and you're clicking on, that's kind of weird. You see how like when I click on this, it like has a hard time because it has to reload all that context is probably the problem. But anyways, like I was saying, even if you go here to GPT-4 and you click on Code Interpreter Beta, I have no idea if that's what's actually happening, right? It's like OpenAI is kind of secret, and they're not like, you know what I'm saying? They could be running GPT 3.5 and I have no idea. And I'm sitting here thinking that I'm using GPT-4. So I don't know. Actually, you know what? That's a good transition for talking about the GPT-4 explained that came out. So let me actually open that up. Let's go on Discord real quick. There's a new update. All right, I guess we can download that. Can I just open Discord? This is how you install. You open show info. Ooh. So it's in our It's in our downloads folder. File browser. To our downloads here. Let's open with archive, open with other application. Software install. Select. This is how you install stuff on Linux. Potentially unsafe. That's fine. I trust it. Oh my god. Actually, you know what? Why don't we just ask ChatGPT for this? Provide a terminal, a Ubuntu terminal command to install a .deb file I just downloaded. So let's go here. CD downloads. We're going to sudo dpackage -i discord deb. I typed that wrong. Okay. Right. Good shit. Let's go into our here, and then here we go. This is what I was looking for. I was looking for this. Okay. We can't access this thread. What? They already got rid of it? GPT-4 explain. Dude, this is kind of sketch. Huh. Wow. So I know that there was already issues with this whenever the whenever this guy leaked this information. Apparently he got sued or something, or like they asked him to take it down due to copyright. And it seems like it's the same thing has happened again, but this time on Threadreader or whatever the app was. So damn. Fucking OpenAI being super secretive. GPT-3. Let's see if we can find this. GPT-4 explain Threadreader. Somebody else hopefully copy pasted it. Damn, author blocked. Did someone like fucking Wayback Machine? This is just like some random influencer thread. Fuck, dude. You can use archive. I sent the link on the Discord. Yes, dude. Thank you so much. Thank you, Erland. Perfect. All right. So this is, what is archive? Is this basically like internet logging? Time capsule for web pages. Takes a snapshot of a web page. Will always be online even if the original page disappears. Perfect. It's exactly what we wanted. Fuck people who are trying to censor this, you know? Of course, this kind of reads like a AI influencer post. Everything is here. Click to find out more. Okay, but I read this a couple days ago. Let's read it again. GPT-4 is more than 10 times the size of GPT-3. We believe it has a 1.8 trillion parameters across 120 layers. So let's kind of get an idea of what that I'm saying, like, how can we combine this with the code interpreter? You know, it'd be kind of cool if we could copy paste this text into the code interpreter. Can I copy this? New chat, GPT-4 code interpreter. I am going to, here is some information on GPT-4. I will copy in a bulleted list. Use this information to make conclusions. I don't know, give it that. Mixture of experts confirmed. So mixture of experts is a very popular technique on Kaggle and any kind of competitive ML, but it has some drawbacks, right? Basically, what you're doing with a mixture of experts is you're using a bunch of experts where each expert is itself, it's basically just a model. And rather than just using one model and doing inference once on one model and you get one answer, you do inference on many different models and you get many different answers, right? And each of those models, you usually train them slightly differently, right? And the positive of this is that each of those models that is trained slightly differently, usually on slightly different pieces of your data set or slightly different mixes of your data set, they're going to produce a slightly different answer. And generally the consensus answer out of all of those experts or models is going to be slightly better than the individual answer from a single model. But why don't we see this everywhere in production ML? And the reason you don't see this everywhere in production ML is because it increases your inference cost, right? So rather than just having to perform inference on one model, now you're doing inference on however many expert models, which can be huge, right? So this was popular in Kaggle competitions because in Kaggle competition, 10xing your inference cost is worth it if you get 1% improvement, because at the very top of the competition leaderboard, that 1% can make or break everything, right? It's like you're pushing for every single possible juice of performance that you can. But it was a little bit unusual to hear that they were doing this for GPT-4 because GPT-4, right, they're releasing this to millions of people and millions of people are using it, which means that you would think that they would be incentivized to keep the inference cost as low as possible. So the fact that they chose a technique that gave them better performance at the cost of a much greater inference cost was kind of unusual, right? And it kind of, to me, it shows their kind of VC mindset of like, hey, it's worth burning a bunch of money to get users, right? Like that's how VCs think. VCs are willing to burn money if it means they can get users, versus I would say most sane people don't think like that. Most sane people are like, hey, if it costs way too much money to do inference, then we should be charging the users for this, or we should figure out a way to reduce the inference costs, and so on. Okay. They utilize 16 experts, which is about 111 billion parameters for MLP, the multi-layer perceptron. These experts are routed per forward pass, 2 per forward pass. 2 of these experts are routed per forward pass. So what does this mean? It means they only use 2 of the experts? Doesn't make any sense. Each forward pass inference only utilizes 280 billion parameters. This contrasts with the 1.8 trillion parameters that were required per forward pass per a purely dense model. So a sparse model is a model that has been pared down, right? Generally, sparsity refers to a technique where you reduce the model size by pruning the model weights, right? Sparsity, deep learning. We've reviewed this concept before, but generally, the best way to think about this is that you're getting rid of some of the weights that are not really doing much, right? So if you have like a neural net like this, right? This is just a little multi-layer perceptron, right? There's multiple layers. This is the input layer. Then you kind of move and you have, let me make this a little bit bigger. As you move forward, right, you have to basically calculate the value for every single one of these neurons, and that's what inference is, right? Your inference cost comes down to how many calculations you have to do at every single one of these little neurons as you push the information through your neural net. So when you sparsify a neural net, what you're doing is you're getting rid of some of these, right? Maybe here it turns out that the weight for this little neural net here is just a bunch of numbers that are very, very tiny. They're very, very close to zero. This neuron ends up not making much of a contribution. So you can identify that and then get rid of it. And then you see how there's less neurons in this net. So therefore the inference here is going to be cheaper, right? Because there's less calculations to do. So sparsity is a good way of reducing the inference cost. And it's not going to be as good as the original model, the original dense model, but the trade-off is favorable, right? So you might lose a little bit of performance and gain way better inference cost. So it's a popular technique for sure. So this tells you that they're using a sparse version of their model. Let's put that in there as well. GPT-4 is trained on 13 trillion tokens. These are not unique tokens. They count the epoch as more tokens as well. Okay, so what do they mean by this? So when you train a machine learning model, you're training it on a data set. And oftentimes, you're not just training on that data set once, you're training on that data set multiple times, right? And each time you train on the data set, it's called an epoch, right? And you can train on the same data set 100 times, right? 100 epochs, where basically you just keep feeding the same data set to the model over and over again. And it's not exactly the same because usually you're applying some kind of data augmentation, right? So in the computer vision world, right, you might feed the entire data set many, many times to the model, but each time you feed it to the model, you're shuffling it. So each batch is a slightly different sample of the data. But then not only is it shuffled, but then it's also, you're applying maybe some cropping or some left-right flipping or adding Gaussian noise or some kind of data augmentation technique. So the images themselves are also slightly different, right? So the stronger your data augmentation, the more you can kind of just keep doing these model epochs. But here what they're saying is that it's trained on 13 trillion tokens, but it's not 13 trillion token size data set. It's a smaller size data set that has been fed multiple times. 2 epochs for text-based data and 4 for code-based data. Okay, so we don't know what the text or the code-based data means right now. There is millions of rows of instruction fine-tuning data from Scale AI and internally. So good old Scale AI, back when I was doing a startup, this was actually one of our competitors, so I'm very familiar with them. You know, every time I did a pitch deck and I pitched to VCs, I had a slide with a bunch of competitors, and Scale AI was one of our competitors. So Scale AI originally was based on this data labeling for autonomous vehicles. So basically what they did is they had this little front end kind of interface that allowed you to basically draw little bounding boxes, like here, for example. Here, this is a 3D bounding box. This is a car Velodyne, right, that sits on the top of the car, and it basically, each of these little dots is a distance measurement, and you have these giant point clouds, is what they're called, is a cloud of points. And in order to use them in kind of the more classic computer vision supervised learning algorithms, you needed a target, right? So you need to say, this is a car, this is a person, this is a traffic cone, and somebody needs to go through that and label it, right? So there's literally a human being that is sitting here and by hand, like drawing a little box and saying, this is a car. And that was such a painful process that these data labeling services started to pop up, where basically people said, hey, rather than you doing that, I have a bunch of people in the Philippines, and you pay me, and then I'll pay them 3 cents an hour to draw boxes on your images, right? And that's what Scale AI did, right? That was kind of the bread and butter of Scale AI for years. But now, of course, they've kind of grown from that because increasingly more and more of the data labeling, I think data labeling is kind of going away a little bit, and now it's more about data cleaning and data set management, and they have some products here, for example, Nucleus, which is kind of an exploratory data analysis tool. I don't know. I'm not a huge believer in Scale AI, to be honest. I think they're just a collection of a bunch of weird services. Like, it's not a single unified product. It's kind of just like this weird VC Ponzi scheme of like vague ML services, but it does seem like they potentially managed to land a contract with OpenAI to clean a bunch of text data, which is interesting, right? And in the world of enterprise businesses, right, Scale AI doesn't really care about individual little people, individual little developers. You're not going to make a ton of money in order selling something to individual people. That's what I tried to do in my startup. Is we were trying to sell machine learning tools and software to small startups and like kind of more individuals and developers, but you're never going to make money with that, right? If you want to make actual money, you have to basically get these juicy deals, right? And the reason they're juicy is because, like, hey, okay, you get a deal with, for example, an autonomous vehicle company. They'll pay you $500,000 for the whole year, right? So you have a $500,000 contract basically guaranteed for the whole year. So that is the core competency of Scale AI. What Scale AI is good at is they have like corpo salespeople that can sit there and negotiate a $500,000 contract with a big company like OpenAI. So it seems that's what happened. Is basically they got a contract to clean a bunch of text data for OpenAI. U.S. government handshake Scale AI. Yeah. I think they clean a bunch of U.S. government data as well. Okay, let's put that there. All right, and if you just joined, we're making a bulleted list of these things, and we're copy-pasting them into GPT-4, and then we're going to see what GPT-4 tells us. Maybe it tells us something interesting. I'm putting it into the code interpreter because I want it to use math. I want it to basically potentially write a little Python script where it calculates the total amount of flops or something. I don't know, right? There's a lot of numbers in here, so I think the code interpreter will do a better job. There was an 8K context length in the pre-training phase. The 32K seek length version is based on fine-tuning after the pre-training. Good old context length. There's a lot of hype around, or not hype, but just a lot of chat around the context length. The context length is basically just the receptive field of a text model, right? So receptive field net. So receptive field is a terminology from a convolutional neural net, but basically it's this idea of like, okay, well, how much of the image is this particular part or this particular level of the abstraction capable of paying attention to, right? It's like an idea of like how wide is the net at the very bottom. So that has a different meaning in a large language model, right? It's looking at this sequence of text, and then it's like, how long is that sequence of text that it can pay attention to, right? And it seems like the GPT-4 is at 32K, but a lot of the papers for these context lengths are misleading because they advertise a very large context, but the problem is that the quality of that signal or the ability of that signal to actually propagate up in the hierarchy of the neural net is lower, right? So if you have a very small context length, the model is able to pay attention to more, it's able to pay attention to every single token in that sequence very carefully. But a lot of the ways that people are increasing the context length, they're making the context length bigger, but then the model is effectively paying less and less attention to every single token. So the quality of the signal propagating upwards is actually lower. So that's maybe a little rant on context length there. June. I wonder how exactly they did the context length, like whether they did positional encoding interpolation or just extended them for new positions. Yeah, I don't know. But I doubt they did anything super tricky because there's so many other moving pieces here that they probably tried to keep it as simple as possible. Batch size was gradually ramped up for a number of days on the cluster, but by the end, OpenAI was using a batch size of 60 million. This is probably 60 million tokens, if I had to guess. But these huge batch sizes, you can only do that if you have these parallel training setups, which means you have a bunch of GPUs kind of acting in tandem, right, and synchronously. Or not technically synchronously. Usually they're like kind of operating asynchronously to some degree, and then doing a kind of a exponential moving average situation. But big batch sizes are good. Divide this number by the sequence length to get the real batch size. Stop with the misleading numbers already. Parallelize across all their A100 GPUs. Utilize 8-way tensor parallelism as the new limit for NVLink. So tensor parallelism, there's different types of parallelism when you're training a deep learning model. There's data parallelism, model parallelism. I think tensor parallelism refers to a type of model parallelism. So in data parallelism, you're splitting your batch across a bunch of different GPUs. Your data. So your batch itself is being cut into little pieces and then split across a bunch of GPUs. In model parallelism, you're cutting your model into little chunks and then putting each little chunk of the model on its own GPU. So different GPUs are doing inference for different and calculating gradients for a different part of the model, right? And then there's also layer parallelism where different layers are being split across the GPUs. So basically how you decide to take the big ass batch and the big ass model and then split that across a bunch of GPUs is the type of parallelism that you're using. And then NVLink is, this is more into the actual hardware world, but it's like how you actually interconnect a bunch of GPUs in like a cluster. Wire-based serial multi-lane communication link. So if you actually remember, if you're old school enough to remember these things, yeah. So if you put two GPUs on like a consumer motherboard, they sell these like little wires that you can use to connect them. And this is the OG NVLink, right? So you see here, for example, what is this little GIF showing you? This GIF is showing you the CPU here, or basically something that represents the computer, and then something that represents the GPUs, and then if you don't have this NVLink, the GPUs have to communicate via the CPU and the normal computer itself, right? Anytime if one GPU wants to send information to another GPU, it has to send it to the CPU, and then the CPU has to send it to the other GPU, right? So you're going through this longer path here. But with this NVLink, the GPUs can communicate to each other directly, right? So it's much faster. And this is kind of the most simple version of NVLink. I think at this point, like, the complexity around NVLinks in a server kind of data center is pretty hardcore. You know, they have these like computational meshes almost, and like, I don't know, I can't pretend to know the way that NVLinks work. And yeah, look at this. So this is much more complicated, right? So I'm familiar with this, where you just connect two little GPUs locally on your computer with that little wire, but here's actually what the NVLink looks like for a system with 4 A100s. See, so here's a server rack, right? This is a single drawer that you would push into one of those tall server cabinets in a data center. You see here there's 8 GPUs. And I guess they're connected like this. I don't know exactly what this refers to, but Okay. We'll leave it at that. Joe Chan, or Joe CH. I wish somebody did commentary on Hungry Hungry Hippos, which was supposed to be an actual alternative to Transformers without N squared. I wonder if it is another vaporware or is it something new. Hungry Hungry Hippos. Hungry Hungry Hippos. Attention. Deep learning. See if we can find it. H3 and the language. How old is this? This is 2023. Is this the paper? Hungry Hungry Hippos. Here we go. So this is Stanford University of Buffalo 2023 paper. State space models. Despite scaling nearly linear in sequence length, state space models are still slower than Transformers due to poor hardware utilization. Yeah, and this is kind of important. You know, I mentioned this before, but like design decisions that are in theory more optimal sometimes are not in practice more optimal, right? That the final speed of a particular training algorithm and a particular model architecture is not just based on kind of the equations and the math and the total number of matrix multiplies. It's actually a more complicated equation, right? You have to think about the hardware and the hardware that you have available, how the different, even things like the NVLink, right? Like, and then how that algorithm is actually compiled down into kernels that actually run on the GPUs, right? And there's some algorithms that on paper, they seem like they should be faster, but when you actually compile them down into kernels, they're actually slower, right? And they utilize the hardware worse, and that's kind of what they're referring to here. So maybe to answer your question, Joe, the Hungry Hungry Hippos might seem better on paper, but then when you actually try to implement it and run it on a bunch of CUDA GPUs, it doesn't actually work. Or it's not actually faster, it's actually slower. We use synthetic language modeling to understand the impact. H3 matches attention. And it comes within 0.4 perplexity of Transformers on open web text. To improve the efficiency of training SSM on modern hardware, we propose FlashConv. FlashConv fuses a black box fast Fourier algorithm to improve efficiency on sequences up to 8K. Yeah, I mean, this is kind of hard. Like, we read some other papers that were kind of like proposing new things like this. I think the RWKV is another kind of weird model architecture that is kind of like Transformers but not like Transformers. But I don't know, the machine learning research world is littered with these type of things, right? Like capsule nets and graph neural networks. There's so many like interesting weird paths that kind of just ended up dying because nobody went down them. But who knows how many of those weird paths that we didn't go down are actually the correct path, you know? Maybe capsule networks, like if you actually scale them by 100x, they end up being way better than vision transformers. But who is gonna have the money to make that bet, you know? All right, let's get back to our GPT-4 explained here. Training cost. OpenAI's training flops. Actually, let's write this down. Put that there. OpenAI's training flops is that e to the 25 on 25,000 A100s. That is fucking huge. Part of this extreme low utilization is due to an absurd number of failures requiring checkpoints that needed to be restarted from. So, I mean, obviously when you're training a machine learning model, if you run into an issue, you basically kill it, especially if you're doing everything in these like huge parallel setups like that, right? It's not something where you run into an issue and it's just one GPU that has an issue, and then you can basically turn off that GPU and then turn it back on, right? The whole system needs to work together in parallel. So if there's an issue, you need to basically spin down the entire cluster, and 25,000 A100s probably takes a while to get this spun up. But this actually reminds me of OpenAI Dota model surgery comment. So I remember that. Yeah, this is an older paper at this point. It might not even be this one, but back when OpenAI was training their Dota paper, or their Dota model that plays Dota, they talked about this concept of like surgery, right? Where basically you're constantly checkpointing and then also trying to figure out a way to start from checkpoints that might not actually be the checkpoint or the same model that you're using. So if you're writing PyTorch code for a model and pushing gradients into it, as soon as you change anything in that model, older checkpoints are probably not going to load anymore, right? So there's this kind of one-to-one relationship between the particular version of the code base and the particular like checkpoint that you're loading. So if you change the code, the old checkpoints often don't load, right? There isn't kind of like a backwards compatibility like that. Generally, that's not the case. So I kind of vaguely recall that, yeah, this concept of surgery here, where they call surgery transfers trained weights from one network to another after a selection process to determine which sections of the model are unchanged and which must be reinitialized. So maybe saying, okay, well, we added this new little layer over here, and rather than retraining the entire thing from scratch, we're going to basically take our checkpoint from the previous version of our model and copy over a couple of these layers, which we know are fine, and then reinitialize this other layer. So this kind of surgery concept is something that OpenAI does have experience with. And here you go. Here's the final sentence, I guess. Cost in the cloud, the training cost is about $63 million. So that's what it takes to train a state-of-the-art LLM, is $63 million. I don't know who has that kind of money, you know? And I guess that's it. Okay. Let's give this to Copilot, or not Copilot, Code Interpreter, and let's see what it tells us. We can make several conclusions. Considerably larger represents more than a 10x increase in size. Efficient inference only utilizes blah, blah, blah. Data and training. Okay, this is just basically just re-copy pasting everything that we gave it, but in a more bulleted format here. Let's see, how many batches, let's see if we can answer that. How many total batches did the model see during training? So it has to basically look at the total number of steps, which they said, which is this. The 13K tokens is effectively just the total number of training steps, or at least you can get it from that. Show work. Yeah, so it counted the total number of tokens, and then it said per expert you have this many tokens. Where did it get this number? 7.5. .5 tokens per expert, so that's where it's got that. And then it divided the total tokens by the batch size per expert, and you got total number of batches. Just there you go, 1,733,000 total batches during training. Let's ask it another question. So we have 25,000 A100s. What is the total VRAM for the training cluster? Okay, so it got the correct number of GPUs here. Let's see if it knows. Oh, look at that. So it said, okay, A100 GPUs come in two different flavors. There's a 40 gigabyte version and an 80 gigabyte version of the A100. And it said, created variables for those. And then it basically just multiplied number of GPUs for each one. There you go. Can you guess at the whether, let's see, can you make an educated guess as to which A100 type was used based on other information? Like the batch size, training, flops. Let's see if we can get it to do some. Okay, this is just kind of more generic logic here. Larger memory would be more able to handle large batches, blah, blah, blah. Total training flops. A GPU with more memory can handle more operations. Significantly larger. This huge model will require more memory. With these points suggest the use of an 80 gigabyte A100 without explicit information is challenging to be entirely certain. However, given the core requirements of training such a large model, it's reasonable to hypothesize might have used the 80 gigabyte variant. Okay. What else can we ask it? OpenAI's training flops. Cost was about $1 per A100 hour. Let's see if it knows cloud costs. The cost of $1 per A100 hour. How does that compare to other cloud offerings? Cost of $1 per A is significantly lower than typical cloud offerings. AWS's P4D 24x large instance comes with 8 A100s, is about $32 per hour. Is this correct? Let's check that. Vantage.sh. This is the 8 A100s. This is the correct one. And what do we got for cost here? Is there a cost? $32.73 per. This is correct. Nice. Other cloud providers have comparable pricing. Large organizations often negotiate custom pricing. Could have used their own hardware infrastructure. I don't think they did. They used the Azure cloud. And I think this is the important thing to realize, right? Where it's like Microsoft gave them a bunch of money, but they're going to use that money on Microsoft Azure cloud, right? So it's like if you own a bakery and then you go to the hobo and or homeless person and you give the homeless person $100, but then you tell them that they can only use that $100 to buy from your bakery, right? So at some point, you're kind of just giving that $100 to yourself. So there's a little bit of that going on with Microsoft and OpenAI and their relationship, where Microsoft gave them a bunch of money, but a huge chunk of that money is just going right back into Microsoft because they're using it to pay for the cloud. Hey, are you going to archive this live stream like all other paper reading streams? Yes. I don't explicitly archive it. YouTube just does that. So I just come on here and I go live, and then YouTube saves it and puts it on there. And it ended up not being a lot of coding, so 1 a.m. here as well. Oh, shit. I'm sorry, guys. We're just kind of hanging out, you know? I feel like you guys should get some sleep, you know? Sleep is good. Okay. What else can we do here? So we looked at GPT-4 explainer. We looked at the code interpreter. And we also see, what can we waste our time with? We went through pretty much everything I had. Keras core, we also looked at that, but it's actually a nothing burger because they didn't even release it. So why don't we do this? Here's something I do when I'm looking for interesting things to look at. So you go into GitHub, go into the home, and they used to have a trending, but they just changed this. Let me see if I can find this. For you, filter, new repository, explore repositories, explore more, trending. Here we go. Trending repositories for the past week. Okay, so we got Noodle, MetaGPT, multi-agent meta programming framework. What is this? MIT licensed. Contributors seem to be a bunch of open sourcey looking people. One line requirement outputs user stories, competitive analysis, data structures, APIs, and documents. Product managers provides the entire process of a software company. What the fuck is a SOP? Let's ask GPT. What does SOP mean in the above text? Standard operating procedure. Yeah, lots of AI stuff trending for sure. You see, this is all Chinese stuff here. WeChat roadmap. So I think this is Japanese, right? This is the Japanese kanji. This is the Chinese README. Python startup design a Rexus like Toutiao. Oh shit, they have a Docker image. Perfect. Let's see if we can get this. So Docker pull, put that in there. So here you go, Docker went and it pulled this Docker container here, which basically has all the dependencies that we need for this repo already basically pre-installed. Very convenient for us. We need to prepare this config. Okay, this is a little sketchy. They're making us put this config object. It's downloading over 2 gigs of data, so that's probably the actual model. I bet you we're going to have to put in our OpenAI API key here. Yeah, configure OpenAI key. Alright, so we got this downloaded. Let's copy paste this stuff in here. Cannot make directory -opt. Sudo make directory -opt. Oh. They want us to run this with sudo, but I'm only going to run this make here with sudo. Okay. Now let's run this. Permission denied. I don't like having to fucking sudo everything. opt meta gpt config.yaml. There's nothing in here. Well, actually, we can probably just copy the config that they provide here. Config.yaml. Copy. Then all we got to do is just vim. Put that in there. Put this entire crap in here. Oh my god. Everything is sudo. Okay. Let's copy paste our key here. So obviously I gotta be careful here because you guys are gonna totally take this key from me. So I'm gonna make a key, but I'm gonna delete it after this stream. Something ironic about using Google to sign into OpenAI. Create new secret key. Stream. Copy. Done. And let's use GPT-4. Yeah, that's fine. All right. So now we have this key. So technically you guys can use the key right now while I'm still working on it, but I will delete it. So don't try to use it to answer a bunch of crazy questions. All right, so now we just run this image. Access the running container, and we do docker ps. You see, there we go. Here's the Docker container. Let me move this. It's probably hard to see this, sorry. My face is probably in the way. but you can see that there is a running Docker container here. And then we're going to do this. The -it will put us into the Docker container, kind of like if you were to SSH into something, basically. Okay, so now we're in the Docker container. You see it has just one folder here, the MetaGPT repo. And it wants us to go into the MetaGPT repo. And then it wants us to do startup.py. Write a CLI snake game. I find Docker very confusing to use. Yeah, you get a little used to it. Once you kind of understand the basic abstractions, it's fine. But I don't know. I like it. I actually am using it for the project that I was intending to work on today before we got distracted by all this other stuff. But in this project, I have different models. So I'm basically, I have the segmentation model, and then I have the Stable Diffusion XL model. And I'm putting both of them in Docker containers. And the reason you want to do this is so you can isolate the dependencies, right? Docker is very convenient. It's a way to basically wrap all the dependencies you need into one little thing, and then you can basically run it separately from everything else. So you see here how just to get this repo working here, because they have this Docker container, I was just able to install it, get the Docker container, and then it works fine, right? I didn't have to sit here and pip install things. I didn't have to conda environment. I didn't have to go and fuck with my CUDA version and fuck with my NVIDIA driver version, right? It just works. So that's the advantage of Docker, is this containerization. And then if I wanted to run this on the cloud, it would be way easier as well, because I wouldn't have to, I could just provide the container and then the cloud will be able to pull up all those dependencies. Okay, so what the fuck is this doing? This is creating this kind of like almost like a requirement document thing. Create a simple, I want to be able to easily understand. Snake game by Google. Competitive quadrant chart. This is like words that I'm not PM enough to understand here. Can I like Control C? Control C. And also let's look at the usage. How much did this just use? API reference account, pricing. I think account, usage. Select day, today. Huh, it's not updating. I mean, this is sloppy by OpenAI, but I hoped that I would be able to tell how many requests it made to GPT-4, but let's do this. Write a stable diffusion LoRa or fine-tuning LoRa package or module package. Let's see. So it spun up a role. I'm assuming a role is basically like the system prompt, and it has a role called Alice, which is a product manager. As per the request, we need to develop a stable diffusion fine-tuning LoRa package. Ooh. It doesn't know what LoRa is. Look at this. It thinks LoRa means long range, which is not correct. LoRa means low rank adaptation. So technically it fucked up right there. Let's see what else. I want to easily install and set up the LoRa package so I can quickly start using it. This doesn't make any sense. Competitor A. Competitive quadrant chart. Oh, I know what that is. Yeah, this is whenever you're doing like a pitch for investors and you have there's a type of slide. competitive quadrant chart. I'm pretty sure we had one of these in our startup, but you basically put you and your competitors on a chart that basically usually has two different dimensions here. For example, more expensive, less expensive, more convenient, less convenient, or any two dimensions that make your startup look good. And then you put your startup and then other competitors. So this is kind of what it's doing here, you see. Actually, and you know what we can probably do here? Look at this. Let's do this. Let's copy this competitive quadrant chart, and let's see if we can get Copilot to plot it for us. Can you create a plot of this competitive quadrant chart? Should be stable and efficient. We will use several open source libraries. Pylora. This is totally made up, right? Yeah. Huh? Maybe there is a Pylora? There's no way it's actually referring to this. Yeah, this is like some weird communication frequency. Okay, this is like not at all. So yeah, it made up a package here. Pylora is not a real package. tk-enter is a package. I would not use tk-enter for a user-friendly GUI. That's a terrible design choice. There's a way better front ends. I think Grad.io is kind of the cool kid one now. That's the one I've been using, but even that one kind of feels clunky. I feel like there's better solutions for GUIs. LoRa Fine Tuner, Setup Tests, Diffusion Tuner, Streamlit. Streamlit, is that what the cool kids use now? Look at this. Here's the actual competitor quadrant. Low engagement, high engagement, low reach, high reach. X-axis, low reach, high reach. That's correct. Y-axis, low engagement, high engagement. That's also correct. I don't like the fact that it chose the same color and symbol for every single one of these. Can you create that plot but choose a different marker for each competitor? And then here's like a kind of generic data structure and interfaces. I mean, these aren't really useful, to be honest. Like it has like this random device manager class here to add device, remove device. Like, I don't think this would actually be helpful. Oh, look at this. It did choose a different symbol. That's kind of clever. I like that. Dude, Code Interpreter pretty good so far, you know? We've been kind of throwing all kinds of things at it. We were throwing Docker containers at it. We threw an image at it. We threw CSV files. And it's kind of gotten everything so far. That's pretty impressive. But this whatever this is here, this Meta GPT, not impressive. It's hallucinating Python packages. It's running into weird errors. I like that it's in a Docker container. You know, this is clean. You know, the Docker installation, definitely appreciate that. But this itself, kind of garbage. All right, so let's exit out of that Docker container. Let's Docker PS. I think we got a Docker kill, this one. All right, so we killed it, and now we type Docker PS. You see it's not there anymore. But I also don't want to keep this crap on my computer, right? It's like a 2 GB Docker image, so you can do this command here, docker rm-af docker ps-aq, and that'll basically kill or remove. So if you docker ps-a, docker image ls. So let's make this a little smaller. Still there. We need docker image ls and then docker image prune. Is that the right thing we need? No, I think it's docker image rm probably. And then we got to do this. Okay. Docker image ls. All right, we got rid of it. Perfect. Okay, so we no longer have this Docker container. But kind of cool. I'll give them a little star for the effort, but I don't know. Didn't work that great. Let's see what else we got. Let's go back to trending repositories. June. It would be really great if they could actually manage to get JavaScript stuff running on code interpreter like React, although I'm not sure that's going to be possible. Yeah. It could be cool to do that. I don't know. Like, I'm honestly a Java noob. I have done a production Java commit. So when I was working at Weights and Biases, I made some changes, and the changes had to have a corresponding change on the front end, and the front end is written all in TypeScript, I want to say, which I think is Java, right? Yeah, it's basically Java, but dude, it's so gross. Like the design patterns that people use in TypeScript just make my Python brain explode. I just don't like them at all. But yeah, I don't know, it'd be good. It's interesting to know where, like, something I think about all the time nowadays is where software is going to go, because it's like these LLMs are just so good. Like this code interpreter, you know, if everyone starts doing exploratory data analysis in code interpreter, don't you think that Matplotlib will start to change their API to favor LLM use over human use? And I feel like won't front-end frameworks and won't deep learning frameworks and won't all these different code packages start moving in a different direction if an increasing amount of the usage is through LLMs? I don't know. I feel like there's a lot of disruption that is going to happen that people aren't accounting for, and it's very difficult to predict. Okay, let's see. What else is popular right now? So, assembly, C, Python, natural language. Yeah, that's what I think that too, RW. I feel like Python is actually going to disappear, and what you're going to see is kind of a natural language coding language. I don't know what it's going to look like, but it's basically going to be like some set of conventions and pattern. It's basically prompt engineering, right? It's prompt engineering, but you'll be using kind of a specific type of language to describe what you want. And this has already happened before, right? So all of us are familiar with Google, right? And whenever you're searching for things on Google, you're using a kind of a coding language, right? It's like, you know, like if you want to find something about LoRa, like I'll type LoRa, but then I'll also type like deep learning, right? So like what I type into the Google search bar is like some weird language that I've learned over time that I know is good for finding the things I want to find, but there's going to be equivalent for that in terms of like how do you interact with code interpreter. I don't know. I'm not making a lot of sense, but hopefully the vibe that I'm trying to talk about goes through here. High-speed downloader, open source enterprise QA, chat law. What is this? Allows you to ask natural language questions against internal documents and get back to reliable. So this is probably just a vector database with OpenAI. README backend. Let's look at their Docker file. Where's the requirements.txt? Is this OpenAI? Yeah. So there you go. There's the OpenAI. They also have the Python API for Google though, so that's kind of interesting. And they have transformers just randomly as well, or TensorFlow, sorry. So TensorFlow is a very heavy dependency, so you generally don't want to be seeing, like, if you're using OpenAI's API, then why the fuck do you have transformers here? Or TensorFlow. TensorFlow, just get rid of that. Okay. Let's see. Here's another basically same exact thing. Quiver. Dump all your files and chat with it using your second brain. You can use Anthropic, which is Claude, which is basically an OpenAI competitor, or GPT 3.5 or 4. And then I think Vertex AI is a vector database. No, Vertex AI is a ML platform that allows you to train and deploy ML models in AI applications. Huh. Provides tools for model version control and monitoring throughout model life cycles. I always find that these are always just very heavy and not very useful. These kind of like no-code model training solutions, basically. I just always feel like they're trash. But everybody has a Discord. Everybody has a cool logo. Advanced AI. How much do you want to bet it's literally just OpenAI API? Look at this, a Docker Compose. That's kind of useful. Docker Compose allows you to launch multiple Docker containers. So you see here, they have one Docker container for the front end, and then one Docker container for the back end. Right? So the back end mounts your Google Cloud config. Volumes are basically like you create a folder that exists both in your host machine, the local one, and then the Docker container, and you can share the information between them. So in my project, I mount my data directories and my model checkpoints. So one way to have your model checkpoints inside a Docker container is to like literally copy them in as part of the Docker container when it builds, right? So whenever this Docker container builds, you would copy the specific model and then it would have it in that Docker container. But the problem with that is that if you're doing a lot of debugging, you're going to be constantly rebuilding this Docker container, and then you're going to have to keep recopying that thing over, and it's also going to increase the size of your Docker file. So I generally just mount my model and my data as volumes. Environments. What is this? This is kind of cool. What is this, like a kind of deployed by Vercel? Automatically deploys your PRs. It's kind of like a CI/CD tools. Need a Supabase. I've heard this term before. What is Supabase? Supabase is a open source Firebase alternative. Okay, so it's basically one of these solutions that gives you a bunch of things that you already need. So you start, gives you a database, gives you authentication, right? So the ability to create users, authenticate those users, instant APIs, edge functions, real-time subscription, storage, and vector embeddings. View all examples. So these are different. Is Supabase legit? This is a great YouTube channel, by the way, Fireship. You can access Palm from Vertex AI. Can you fine-tune Palm with Vertex AI? That'd be fucking crazy. Model tuning. As far as I know, there's no service that allows you to fine-tune GPT-4 or Palm or any of those big company LLMs. So the way that all of these kind of like chat with your own data things work is they'll encode all of the data, put it in a vector database, and then you can access it that way. But you could argue that a different way of doing this would be to basically fine-tune on your data. So rather than kind of having this, your information kind of externally stored in a vector database, you could have it kind of implicitly stored in your model by fine-tuning your model. And there's advantages and disadvantages to both of those, but it also depends on whether or not these companies are going to keep these LLMs secret, right? Because if they keep their LLM secret and it's basically impossible to fine-tune, then you're going to see a bunch of vector database style solutions. But if we end up in a world where it's more like llama models and you can fine-tune them really easily, then maybe the vector databases become less important. And then also there's the variable of context size, right? Maybe context size gets so big at some point that you don't need to have this kind of an external storage solution, you know? You just feed your entire database into the model, as crazy as that sounds. Claude 2 is cool. I tried it with some papers, very like it now, just because it feels like a model on the level of GPT 3.5. Claude 2. I mean, Anthropic does have a very clean website, you know? Very clean website, but let's see what they're hiring. This is how you know they're serious. Look at this guy. This guy's got the crazy split keyboard. Threat investigator. Research and engineering. Sometimes you can go on these software engineering job requirements and they'll basically tell you all the stuff that they use here. So Kubernetes is like a cluster management, so an orchestration. So it's basically, think about like a bunch of Docker containers all working in tandem. So they're using PyTorch, good to know. They're using reinforcement learning, so definitely some RLHF. Getting paid $520K. I wonder if that's the TC including stock. You know? Because the thing with Anthropic is they have a crazy valuation right now, right? So you're going to get stock compensation based on that crazy ass valuation. So if you're a believer in Anthropic, then hopefully their valuation goes up over time and your stock becomes worth more over time. But a lot of these AI startups, I think the valuations that they have now are the best valuations they're ever going to have. And I think that the valuations might even go down. So you definitely don't want to be in a situation where a bunch of your compensation is equity and that equity is priced at a valuation that is actually incorrect, potentially even 2x off or something like that. 25% of the time in office. Where is this? San Francisco, CA, or London, UK. So they have like two different offices. One in the UK and then one in San Francisco. All right, let's learn more about Claude 2. Claude 2 scored a 71% on Codex Human Eval, a Python coding test. Yeah, but this is kind of what we've seen before, where I think at this point, like, the Python coding questions in these eval benchmarks have leaked into the training data. So your score on these coding benchmarks is no longer a measure of your model's ability to generalize and your model's ability to actually code. It's now a measure of your model's ability to basically recall a thing that it's seen in the training data, right? So it's almost like an overfitting thing. I don't know. I don't trust benchmarks anymore, TLDR. It is more harmless and harder to prompt to produce offensive or dangerous output. One of our partners is Jasper, a generative AI platform that enables individuals and teams to scale their content strategies. Coding assistant Cody. Claude 2 was trained on more recent data, meaning its knowledge of newer frameworks and libraries for Cody to pull from. This is huge. You know, this is something that I feel the pain all the time when using the OpenAI models, that because they're older, they use outdated function calls and API calls, and it can get really annoying. And that's actually one of the reasons I prefer Bard. When I'm asking code questions, I'll ask Bard because Bard seems to be updated more frequently. Why not Bing Chat? I honestly have not used Bing Chat at all. Try now. I probably can't use it because I'm on Chrome. Isn't this just GPT-4 but through the Microsoft UI? I think so, yeah. It's like literally the same. It's just basically this, but you're using it with a nicer, cleaner UI because Microsoft has a bunch of people who are good at making nice, fancy, clickable UIs. Bing Chat on mobile. It has internet access. I think Copilot has internet, or technically GPT-4 has internet now too, right? Plugins enabled. I haven't looked at plugins in a while. Let's look. Popular, new. All right, well, it's not even loading, so. Wolfram, Kayak, Prompt Perfect. Create and edit diagrams directly in chat. What the fuck? Let's install that. Search and browse the webs using Google search results with keymate.ai. Here we go. There you go. There's a web crawler. Fuck that. I don't want to. Nope. I'm not going to install anything like that. See if there's another web browsing AI that's popular, or web browsing plugin. Browse and QA web page, web pilot. Is this better? Can you browse the web? Let's actually do this. Yes, I can browse the web. Okay, let's ask it something kind of cryptic here. What did Claude 2 score on the Codex Human Eval? What did Claude 2 score on the Codex Human Eval benchmark? Try and find. Let's see if it just can answer this, and then we'll give it the. If it can't answer it, we'll ask if it can find, or if it can use the Anthropic website. Okay. Use this link. It's probably just nuking my fucking usage right now. Let's 95 cents already. What do we use? It was probably all that one repo that we downloaded that was doing weird shitty PM stuff. Seven requests, 3 requests, 7 requests. The prompt is 14,000 tokens. Holy shit, dude, that was expensive. All right, let's go back. What is this doing? However, I can't find the specific score of Claude 2 on this page. Okay, so it wasn't able to find it if we give it that. Let's give it the more specific web page. Try this web page. So this is the actual, this is not just the generic Anthropic page. This is like the specific Claude 2 page. So if it scrapes this whole page, it should find the score, which is 71%. There you go, 71%. Okay. So it was able to search the web page, but we had to give it the exact web page. Kind of interesting. What other positions? Prompt engineer and librarian. The fuck is this? Discover, test, and document best practices for a wide range of tasks. So basically curate like an eval and a benchmark. Build up a library of high quality prompts or prompt chains. So make a bunch of tests. Work with large enterprise customers on their prompting strategy. So this is almost more of like a customer support engineer, but they're calling it a prompt engineer to make it sound cool. But this just sounds like a customer support engineer, which is low-key one of the most annoying jobs, because you basically just have to help the customer and try not to get them pissed off, even if they do something stupid. Equity will be a major component. We aim to offer higher than average equity compensation. Because our valuation is so bloated, we would rather pay you in equity, which is basically monopoly money. Yeah, I don't know. Maybe they do well. Like, if we actually go to Crunchbase, Let's look for Anthropic. When did they raise their money? Here we go. Anthropic. So they've raised $1.5 billion, which is absolutely fucking insane. Wait, what? Look at this. The Series B of Anthropic, which happened in 2022, was led by Sam Bankman-Fried. And this is what I'm talking about here, right? Where actually the amount of money they raised was $580 million, but then if you look at the rounds in 2023, $300 million and then $450 million. So these are technically down rounds, right? And what I mean by that is generally you want your rounds to increase in size as you grow as a startup, right? You basically want $1 million, then $10 million, then $100 million, then $200 million. So it's like every time you raise the money, you want the amount of money that you raise to be bigger so that your valuation also grows. But sometimes your valuation gets ahead of what you're actually capable of growing, and then you have to basically have these down rounds where you get money, but the valuation goes down. But they'll massage everything so that it turns out better. Let's actually check out what Sam Bankman-Fried invested in. So Sam Bankman-Fried, he tends to invest in Series Bs and Series As. So this is kind of like mid-stage investing. It's kind of hard to invest at this level when you're an individual, but he's putting $10 million checks here, which are fucking crazy. $25 million checks. Generally, like individual little angel investors, as they're called. They're called angels because it's just like one person who's coming and giving you money. Like they're not putting in this level of money. Usually, you're putting in like a couple $100K max. You know, even the Jason Calacanis, right? The guy from the All In podcast who's all about startup investing. I think he puts like $25K into his angel investment, so very small amounts. And you put them in at pre-seed, right? Which means like some of the first investments. But here, it seems like Sam Bankman-Fried, he does Series A's and B's, and he's putting in big chunks, that's some big dick energy right there. But I guess it all blew up in his face because he was literally running a Ponzi scheme and a fraud. He was the lead investor in Anthropic and Trustless Media. Web3 production house that combines NFTs and TVs. These just look terrible. Comfortable writing small Python programs. Okay. I'm kind of just wasting time here, though. I'm sorry, guys. Ended up not really doing any coding, more of a hangout session than an actual coding session, but we got to inspect some stuff. I need to go do some IRL stuff, but it was nice hanging out, maybe a summary of what we did. We looked at Code Interpreter, which I was actually quite impressed with. Code Interpreter, very impressive, worked quite well for all the different things we wanted. We looked at a couple trending repos. Most of them just kind of seem like wrappers over OpenAI's API. This Meta GPT was kind of lame, but I liked that it was using Docker. And we also investigated the GPT-4 explained thread, and we actually let GPT-4 itself recommend it, or inspect it. So GPT-4 told us about GPT-4, which was kind of cool to think about. And I'm actually going to go ahead and delete this key here, the stream key. So if you guys froze the stream and copied it, it's no longer going to work. So your nefarious plan is over. Erland, will there be a live stream tomorrow? There will not. I'm kind of busy, so I'm only doing 3 streams now a week, but I don't know. It's always up for debate. I could change. If you guys have any recommendations on the specific times for that work well for you guys, and I don't know, maybe if there's a better time for the streams, or if you would like to see more paper streams, less of these kind of hangout coding streams, definitely let me know. Give me feedback on the Discord. But yeah, thanks for hanging out, guys. Thanks for answering questions. Thanks, Erland, RW, Archer, June, Norman, Asa, all of you guys, Joe, and see you guys on probably Friday. I'll post the stream later today, and we'll see what we do. All right, see you guys later.